Hello guys and welcome to Mossy Maths. Today we're going through the 6th lesson on the topic of differentiation, and in this lesson we're going to be recapping the key points from all of the lessons we've done on this topic. And to do that we're going to be answering an exam question taken from the January 2012 AQA Core 1 exam paper. And this I believe is question 4, and there are 4 parts to this question: part AI, part AII, part B and part C. And they all refer to this graph. So let's get started with the question. Hopefully if you can answer these questions then you should be comfortable with this topic on differentiation. So the question says the curve with equation y equals x to the power 5 minus 3x squared plus x plus 5 is sketched below. And this is the curve. Okay, this is the graph we're told. The point O is at the origin, this point here. And the curve passes through A, which has coordinates minus 1, 0, and B, which has coordinates 1, 4. This is B, and this is A. Okay, and the first thing we need to do is find dy by dx for x to the 5 minus 3x squared plus x plus 5. Okay, so find dy over dx, which means just find the first derivative. So if we differentiate this function, we should be comfortable with this from the previous lessons. We do the power multiplied by the coefficient. Well, x to the power 5, 5 times 1, which is the coefficient of x, is 5, x to the power 4. Now, 3 times 2 is minus 6x, and the x on its own, the 1x, will just differentiate to become plus 1. And the 5, hopefully we remember, just cancels when we differentiate the function. So, this is dy over dx. This is the first derivative, and that's the answer. Okay, that's all we need to do to obtain full marks. We could write the working, so we could write it as 5 times 1 and show what we're doing for each step. However, when we differentiate a function, we're only going to get 1 or 2 marks most likely in an exam. So, we can just write the answer as it is here. Now for part AII, we're told to find d squared y divided by dx squared. Now all that means is we differentiate this function. Okay, we differentiate the function we got when we differentiated the original curve. Okay, so we're effectively just differentiating this twice. So the way we do this is we look at our first derivative and then differentiate it. 4 times 5, that's 20. We take 1 off the power of x, x cubed. Minus, now 6x just becomes 6, and the 1 cancels. So this is our d squared y divided by dx squared. Now for both of these it might be worth writing dy divided by dx equals for this one, and d squared y divided by dx squared equals for this one. But you will obtain full marks for writing that because, like I said, these are only 1 or 2 mark questions in an exam. These are the questions where you're going to be picking up 0 for 3 marks. So these are the serious questions we have to take our time with, and we have to go step by step when answering them. And it is worth double checking these questions. But again, with these ones, although they are quite simple in principle, they will combine with parts B and C. So it's important we don't make a silly mistake in parts AI and AII, because that could affect our answers to part B and C. So again, it is worth just double checking we've done this right. And it is a simple few marks to pick up in an exam. So part B, find an equation of the tangent to the curve at the point A, minus 1, 0, this point here. Okay, so again, the tangent means where we have a line that touches the curve, or touches the graph in this case, at exactly 1 point. And that point is A in this case. So to do that, we first need to find the gradient. And how do we find the gradient of a function? Well, we substitute in our x value that we're given into our differentiated function, our first derivative, which we calculated in part AI. So we simply substitute our x value, which is minus 1, into this, and the answer we obtain is our gradient. So if we do that, we get 5 times minus 1 to the power 4 minus 6 times minus 1, our x value, plus 1. Minus 1 to the power 4 is positive 1, times 5 is 5. Minus 6 times minus 1. 6 times minus 1 is minus 6. So we're minusing minus 6 and then adding 1. Now hopefully we can see 5 minus minus 6 is the same as 5 plus 6, which is 11. Then we're adding 1, that's 12. So this is our gradient. And now we need to refer to this key point here, this tip. And it's the equation y minus y1 equals m times x minus x1. Now this is the equation of a line that we need to use. At GCSE you would have been familiar with y equals mx plus c, but as you've seen in the earlier videos, this is the formula we need to use at AS level. And we simply substitute in the values we have into there. So y minus our y1 is the value of y given to us in the coordinate. Well, that's going to be 0. It's 0 here. Y minus 0 equals m, our gradient, which we've just calculated to be 12. And for this part, you might get 1 out of 3 marks, or 1 out of 4 marks, just for calculating the gradient. Possibly even 2. Okay? Multiplied by x minus our x1 given to us in the question, minus 1. Now we need to simplify this a bit more. Y minus 0, well that's just y, equals 12 times x minus minus 1 just becomes positive 1, x plus 1. Now you could leave it in this form. In the exam, in the mark scheme, it does leave the answer in this form. So that would give you full marks. However, with exams changing and becoming more difficult, I would expect that they could easily just ask you to write it in the form y equals mx plus c. So it's worth doing that and simplifying it down into that form to make sure we definitely pick up every single mark. So if we simplify this, we get y equals, or 12 times x, expanding the brackets, is 12x, and positive 1 times 12 is plus 12. So this is the form we need it in, and that's the answer. So there is the equation of our tangent, and again that's 3 or 4 marks in an exam. And finally, the question says, verify that the point B, where x is 1, is a minimum point of the curve. Point B here. This is the point it's referring to. We've got to show it's a minimum point. Well, what is a minimum point? Well, hopefully you know from my previous videos, a minimum point is the same thing as a stationary point. And the key word from the question is verify. Now, verify just means the same as prove. It's a proof question. It's telling us to show that. Okay, it's telling us to show that it's a minimum point. In some questions it might say determine whether it's a minimum or maximum point. Here it's telling us what the answer is. It's a minimum point. And we have to work out how we get to that. We're basically having to prove that that is the case for point B. And the way we do that is we first need to prove that it's a stationary point. Okay? And by stationary point I mean a point on the graph where it flattens out. So what does that mean if the graph is flat? Well, it means it can't have a gradient. Okay? And if there's no gradient, then dy by dx will equal 0 when we substitute our x value in. So the first thing we need to do is substitute in the value of x given to us into our first derivative, and we hope to get 0, because again, like we did here, we substituted our x value in to our first derivative to find our gradient of the tangent. We do the same for point B, and we hope that if we get 0 as our gradient, then that proves that it's a stationary point, okay? So we substitute 1 into dy by dx into this. So we get x to the power 5, okay? Which is, we substitute it into this, our answer for part AI. That's the thing, you can easily get confused by substituting 1 into the original equation, which you're not meant to do here. So just check that you've done it right. This is what we need to substitute it into. Our first derivative, we get 5 multiplied by 1 to the power 4. Minus 6 times our x value, 1, plus 1. So 5 times 1 to the power 4 is 5, minus 6 times 1, minus 6, plus 1. So we get 5 minus 6 plus 1. That verifies that this is indeed a stationary point, because 5 minus 6 plus 1 is 0. So our gradient is 0. And we would pick up almost half the marks I would expect in an exam, because we've proved that it is a stationary point. That's the first thing. Now we need to show that B is a minimum point. And how do we do this? Well, again, referring back to my previous videos, we substitute in the x value we have 1 into d squared y divided by dx squared, which is 20x cubed minus 6. If we do that, we get 20 times 1 cubed, which is 20 times 1. That's 20. Then we minus 6 from that. 20 minus 6 is 14. And the last thing to do would be to state that as 14 is greater than 0, it is a minimum point. Okay? Because if you look back at my previous videos, if you're not sure, do that. It's worth making sure you understand each point we're going through. If the value we obtain when we substitute x into our d squared y divided by dx squared, our second derivative, if the answer we obtain is greater than 0, it's a minimum point. If we obtain maybe minus 14, that would be a maximum point. So a negative answer is a maximum point, a positive answer is a minimum point. So we've now proved that this is a minimum point, and we've shown it's a stationary point by substituting our x value into our first derivative and obtaining 0 as an answer. Okay? So, that's the 6th lesson on the topic of differentiation. Thanks for watching the video. If you found it helpful, do leave a like. If you have any comments, then please leave them below and I'll try and get back to you as quick as I can with an answer. So thanks a lot, guys, and I'll see you in the next lesson.